Welcome to our next lecture on organic chemistry, and this time is going to be on synthetic routes, as I earlier said in the last video. So we'll be talking about synthetic routes. Just for the main synthetic routes, okay, it depicts that you want to synthesize something, and you have to go through different parts or through different steps in order for you to arrive there. That's what we call a synthetic route. Now, a synthetic route actually expresses the interconnection between different compounds. So it tells you how can you be able to convert from one homologous series to another. For example, how can I be able to convert from an alcohol to an alkene? How can I be able to convert from an alkene to an alcohol? Okay. How can I convert from an alkene to a haloalkane? How can I convert an alcohol to a haloalkane? And all of that. So it gives you the interrelationship between the different compounds. So with this synthetic route, this one you are going to have, of course, you have aliphatic synthetic route and aromatic synthetic route. Now in this particular lecture, I am going to focus on aliphatic synthetic routes. Now with the aliphatic synthetic route, you are going to see the interconnection between different compounds, okay, different compounds. And in the other lecture, I am going to tell you about the aromatic synthetic route. That, I mean, like in terms of the one that concerns just benzene alone, okay. I'm going to discuss all of that, but here now, I'm going to give you two major synthetic routes, which are the step-up reaction and the step-down reaction. These two reactions, you have to know them in organic chemistry, and if you know it, about 90% of your aliphatic synthetic which comes in the GCE is already your success on it is already guaranteed. In fact, you already know that you're going to have it. Okay, so please you pay very good attention to it, and then you get it right. Okay, and after that, I think after I give you the synthetic route, then I'm going to set an example on the board, and then all of us are going to go through it. We're going to go through it together. So here, the very first one that I'm going to tell you an example will be the conversion of CH3 CH2OH. Okay, the conversion of ethanol to propanol. That's CH3 CH2 CH2OH. Okay, it is going to be the conversion of ethanol to propanol. So this is ethanol and this is propanol. So if you understand these two synthetic routes, okay, plus if you understand this plus the example I'm going to solve, then it means that you are already going to know a lot. Okay, you will be able to solve many different examples on your own. Now, very importantly, okay, I'm going to have here, I'm going to have CH3. Here, let's say the very first thing I do is, okay, for this synthetic route, I can be able to first of all convert my alcohol, okay, my ethanol, to CH3 CH2 Cl. Okay. Now my goal here, okay, is to increase. My goal here is to increase the number of carbon atoms in the in the principal chain. So here I'm going to add 2 carbon atoms, but here I have 3. So my goal is to add one of these carbon atoms to the chain. Okay, so how am I going to do it? The very first thing is I can convert my alcohol to the haloalkane, okay, using PCl5. Alright, PCl5, and you always use PCl5 in cold. Okay, that's the condition in which you use PCl5. And then after I've had my chloroethane, I can be able to convert the chloroethane to CH3 CH2 CN. Okay, I add a cyanide to it, so I can use a metal cyanide, maybe potassium cyanide or sodium cyanide, in the presence of in the presence of alcohol in an alcoholic agent. Maybe let's say ethanol. Okay, and please you spell the alcohol in full under that is I warm it. Okay, if I add cyanide in alcohol and I warm, and I'm going to obtain cyanide. So it is going to be a nucleophilic substitution reaction, because cyanide Cn minus is a nucleophile, and the cyanide minus will be replacing the chlorine there. So we call it a nucleophilic substitution reaction. Okay, so now take note between these, this reaction, all right, this reagent here and the reaction condition is different from the one we had during the reaction mechanism of nucleophilic addition, where we had to add, because this one too is kind of yielding, is going to yield cyanide. Okay, the other one we use we're adding hydrogen cyanide to the aldehyde for you to have a propane, for you to have a nitric compound. Now here you are using cyanide bearing alcohol and you are warming, so and the target is different. You want to replace cyanide, you want to replace the halogen in the compound with the cyanide. Okay, then after you do that, all right, permit me to come below due to the space. I'm going to have CH3, okay, CH2. So from here I'll move on to, right, I can move on to CH3, CH2, okay, or I'm going to do this. Sorry. Now from there I can move for me to get to my alcohol. All right, for me to get to my alcohol, because from here my goal of adding the carbon atom to the main chain has already been achieved. So what I need to do is now to convert this group, okay, to an alcohol. I need to convert it to an alcohol, and I need to pass through several routes. Now there are two main routes from here. All right, it doesn't, in the exam you can choose any of them, but there are two main routes from here, and all of these reactions are going to be teaching you some things. There are two main routes. It's either I leave from there and go through a carboxylic acid, so I can be able to convert this cyanide to a carboxylic acid. So I can have CH3, CH2, COOH. So if you look at it, we are talking about, here is an interconversion. So it means no matter the alcohol I've been given, okay, if I'm given the propanol to convert to butanol, I am going to follow the same steps. The main important thing is that for me to convert OH, all right, to Cl, I am going to use PCl5. And another important thing is that if I want to convert maybe a haloalkane to a cyanide compound, I am going to use cyanide in alcohol and I warm, and it's going to, the cyanide will replace the Cl. And another meaning, if I want to convert the cyanide compound, okay, to a carboxylic acid, all I need to do is to add acidified water, okay, and I boil. So please, acidified water is the same as dilute HCl. Okay, you add water, HCl in water. Of course, HCl will give H plus and Cl minus in solution. The H plus will bond to water to form the oxonium ion, and that is the same. So this one, and if I boil, I'm going to obtain the carboxylic acid, and then I can now further convert this carboxylic acid to my alcohol, CH3, CH2, CH2OH. Remember that you can be able to convert a primary alcohol. Okay, you can be able to oxidize a primary alcohol to a carboxylic acid. You add acidified potassium permanganate, okay, to a solution, and you reflux, and you convert this primary alcohol to an aldehyde, and from an aldehyde to a carboxylic acid, and we call that process double oxidation. So it means that if I want to move from carboxylic acid back to the alcohol, I simply do the reverse, okay, which is reduction. So I use lithium aluminium hydride, okay, in this case. And lithium aluminium hydride is a reducing agent which is always used in dry ether. So you could also be able to use sodium with ethanol. You could also be able to use hydrogen maybe in nickel catalyst bed, in the presence of platinum or nickel catalyst bed. I usually prefer to use lithium aluminium hydride, okay, it is highly used, okay, is preferable. So you use lithium aluminium hydride in dry ether, always in dry ether. Alright, so that is all about my synthetic route. And one thing about synthetic route is if you are writing a synthetic route and you have more than 4 steps, alright, if you have more than 4 steps, you have to review your work because it might turn out to be wrong. Most of the time, synthetic routes are usually, good synthetic routes are usually 4 steps, okay, at advanced level. Now here, I could still decide to, so I've gone through one route, okay, to arrive there. I could still decide to go through another route, okay. I could use lithium aluminium hydride in dry ether to reduce the cyanide, all right, to reduce this cyanide to an amine. So I'm going to have CH3, CH2, CH2, NH2, all right, to form propanamine. Now when I have my propanamine, I can now be able to convert my propanamine to my alcohol, all right, to my alcohol. So how do I convert? The main important thing here to know is how do I convert an amine to an alcohol, okay, to OH. I'm going to use nitrous acid, all right. I'm going to use nitrous acid. Now it's either they can write to you nitrous acid like this, alright, below 5 degrees Celsius. But you have to know that the nitrous acid is not actually very stable, so we generate it in situ. In situ means you generate it there and you use it. Okay, you put reagents that are going to generate the nitric acid there, then it's going to nitrous acid in the medium, and then it will be used to accomplish the task, okay, for the reaction. So you add sodium nitride, so a combination of sodium nitride in HCl, dilute HCl, below 5 degrees Celsius, okay, that's the reaction condition. Below 5 degrees Celsius is going to yield an amine. Also, it's going to convert the amine to an alcohol. Please take note that in the synthetic route, we are dealing just with the major products, okay, we are dealing just with the major product. The other small water and other compounds are going to be formed, which are not major and not really considered here. So you see, this is my step-up reaction. So I've left from here. When I came and reached here, there were two possibilities for me. Either I could go like this or I could go this way. So please take your time and you look, you make sure that you understand the reaction very well, because where you are going to know the use of these reactions are going to be when we're doing some synthetic routes, which are actually questions. Okay, but for now, you might tend not to see the importance that much. Okay. Now the next part that we're going to be going to is a step down reaction. How can we rather be able to convert from maybe ethanol to methanol? How can we be able to convert from ethanol to methanol? So let's look at it. Now, conversion of ethanol to methanol is a step down reaction. Just like maybe if you want to convert from propanol to ethanol, okay, it is a step down reaction. Okay, it's a step down reaction. So you pay keen attention again, and then you get it. All right. So, what if I want to convert CH3 CH2OH to CH3OH. How can I be able to do that? Now, the first thing I do is I can be able to convert my CH3 CH2OH to my carboxylic acid first to CH3 COOH. Remember, this is a primary alcohol. I can undergo double oxidation using acidified, okay, potassium permanganate. When I use acidified potassium permanganate under reflux, okay, I am going to obtain a carboxylic acid. And when I obtain my carboxylic acid, I can be able to use concentrated ammonia. All right. Now you can still use ammonium carbonate, but there are going to be some impurities in the compound, and it's not going to be good. So it's preferable to use concentrated ammonia, okay, in alcohol, which can be ethanol, possibly, right, under heat. So when you heat concentrated ammonia in alcohol, okay, with a carboxylic acid, you are going to obtain an amide. So I'm going to obtain CH3CONH2. Please, this group is called an amide, alright, and it's different from an amine. So this is the functional group of an amide. Okay. Now what happens is that this step which I'm about to give you is a very, very important step in organic chemistry. And it is from here that we usually actually remove carbon atoms from the principal chain, reduce the number of carbon atoms in the chain. Okay, and we call that reaction the Hofmann degradation. Okay, I'm going to call that reaction the Hofmann degradation reaction. The Hofmann degradation reaction. It is a very, very important reaction in organic chemistry, which leads to step down of the number of carbon atoms in the chain. So what happens is that I have CH3 C. So that compound there can be converted to, that's CH3 CONH2 can be converted to CH3NH2. Okay, NH2 means that this group here, this carbon atom can be removed plus this oxygen. can be removed, okay, thereby stepping down the number of carbon atoms in the main chain to 1. And what we use there for the reagent is bromine in sodium hydroxide under heat. Okay, bromine in sodium hydroxide under heat. And of course, if we have bromine in sodium hydroxide and we are heating, we are going to remove that CO and we will be left with an amine. So this is methanamine. Okay, and then from the methanamine, of course, this is an amine. I can simply be able to convert the amine to an alcohol. Remember, using our nitrous acid below 5 degrees Celsius, so I use a combination that will give it sodium nitrite in dilute HCl, okay, at temperature below 5 degrees Celsius or from 0 to 5 degrees Celsius. Okay, and so I'm going to obtain my alcohol. That is that about a step down reaction, like stepping down or converting an alcohol to a with one carbon atom higher to another carbon atom with to another alcohol with one carbon atom less. Okay, and that is it for the step down reaction. Then we're going to I will show you another way by which you could still convert this. I just want you to learn some particular reactions, all right, so that by the time we are solving the examples, you should be able to understand better. All right, now that is it. Now I could still take, for me to still to do that conversion, I could still take CH3, okay, CH2OH, all right, and then I will still convert this one to CH3, CH2, CH2. I could still convert it to an alkene, which is 18. And of course, for you to convert an alcohol to 18, use excess concentrated sulfuric acid at 170 to 180 degrees Celsius. So when you use this, all right, excess concentrated sulfuric acid at 170 to 180 degrees Celsius, you are going to obtain CH2, that is, you are going to obtain an alkene. No matter the alcohol, you obtain an alkene. So in this case, we are going to obtain our 18. Now I can now be able to carry out ozonolysis on this 18. All right, can be able to carry out ozonolysis for this 18 to convert it to so if I add ozone, all right, O3, and ozone is usually added in the place of zinc dust. Okay, zinc dust, we add water, all right, at 20 degrees Celsius. Zinc dust, we add water at 20 degrees Celsius. Now when you carry out ozonolysis on that in this compound here, all right, we're going to obtain C double bond O, hydrogen. Now what do I mean by that? When you carry out ozonolysis, please, the simplest way, remember, ozonolysis is a test, is a reaction which is carried out in alkenes to test the position of the double bond in the alkene. So it means that if I'm adding this, if I'm adding ozone to this alkene here, which is 18, all right, the simplest way to know the product will be that each of these carbon atoms is going to pick up an oxygen atom. So it means that this carbon atom here will pick up an oxygen atom. So we are going to have something like this, and this one here also will also pick an oxygen atom. So I'm going to also have H, okay, double bond O, OH. So it's going to have two hydrogens, and so you see all of them are methanol. All right, all of them are methanol atoms. Since this is this is symmetrical alkene. If it was butene, all right, if you take butene and you carry out ozonolysis on it, you are going to have two molecules of ethanol. All right. So if you see, of course, butene maybe being or maybe butanol, butan2ol being converted to say ethanol. Okay, don't doubt it, because if you start with butan2ol this way, you can still carry when you add excess concentrated sulfuric acid at 180 degrees to 170 to 180, you are going to obtain butene. And if you ozonolyze butene, you are going to obtain two molecules of ethanol And then of course, just like here, this one will give me 2 molecules of methanol. All right. So, and from there, from the ethanol, remember you can be able to convert aldehyde to alcohols by using lithium aluminum hydride. So this is my ethanol here. So I can now be able to convert, or let me put it like this. I can be able to convert my ethanol, okay, to my alcohol, CH3OH, okay, using lithium aluminum hydride, okay, in dry ether, okay, using lithium aluminum hydride in dry ether. So you see this synthetic receiving 3 steps, because I just took the primary alcohol, so I took the ethanol, I dehydrated it to have an alkene. From the alkene, I took autolysis to obtain the ethanol. Now from there, this one will be specific for this case. Now if I'm giving, let me say propanol to convert it to ethanol, I cannot use the same principles, because propanol is not going to give me a symmetrical alkene. Okay, it's not going to give me a symmetrical alkene. So the reaction or the synthetic which I showed before this one is going to be acceptable for all. Now this synthetic again can be acceptable, as I said, for conversion of butane 2-ol maybe to ethanol, because if you try writing it, butane 2-ol will be converted to butane to butene. Butene can be ozonalized, and of course it will give you 2 molecules of ethanol, and if you reduce the molecules of ethanol, of course you are going to obtain ethanol. Okay, so that is it for the synthetic routes, for aliphatic synthetic route. Okay, those are the main synthetic routes which you know you'll be able to answer questions. Okay, so after this part, I think in the next part I will try to answer some synthetic routes to you. Okay, and I think in the third part we are going to look at the synthetic routes which contain the aromatic compounds like benzene and so on. Okay, so take a look at this and make sure that you understand it very well. If you don't get anything, you can always rewind the video and watch. And please make sure you endeavor to subscribe to the YouTube channel, and also invite others to subscribe. So thank you very much for watching, and have a nice time.